Hello. In this video, we're going to go through Learning Target 6.2.2, which is identifying the common difference in ratio from sequences. So in this target, we're going to talk about two types of sequences. And a sequence in general is just like a list of numbers. So you can see like an example is right here. This is a sequence. You can do it with other things besides numbers as well, like shapes is a really common one. So it'll be like triangle, circle, square, triangle, circle, and then it'll ask you like what comes next. And in a sequence, there's a pattern. So in this case, it would be a square. So the two types we're going to talk about in our learning target is arithmetic and geometric sequences. They both are sequences of numbers, but arithmetic sequences, you are adding each consecutive term. So to get from one to the next, you're adding. Sometimes it will look like subtraction if you are adding a negative. So I'm just going to put could be positive or negative. So if you're adding a negative number, it really looks like subtraction, but you're adding like a -2 to each one. And the amount you add by is called the difference, represented by D. So a geometric sequence, on the other hand, instead of adding each consecutive term, we are multiplying each consecutive term. And multiplying can sometimes look like division, so I'm just going to write looks like division if it's a fraction. So if I'm multiplying each term by 1/2, it looks like I'm dividing by 2. So if you think you're dividing, it's really geometric and you're really multiplying by the fraction. And the number we multiply by is called the ratio, represented by R. So arithmetic sequences have differences, and that's when we're adding each time, and geometric have ratios when we're multiplying each time. So in the 2.0 level, all you're going to need to do is tell the difference between the type of sequences, so is it arithmetic or geometric, and then whether we have a common difference or ratio, what the value is, and then sometimes it's going to ask you to continue the sequence. So let's look at this first example. The first thing is figuring out if it's arithmetic or geometric. And so basically what I do is I just try to see if it's arithmetic every time. As you start to see more of these, you'll start to get some ideas about like common things that'll tell you whether it's arithmetic or geometric. But you can always just try each one. So to see if it's arithmetic, I want to make sure that I'm adding by the same amount every time. And so what I do is I do the second minus the first. So -8 minus -3. And that gives me -5. So what it's saying is that I'm adding -5 to get from here to here. And it has to be the same on every single term to be able to be real. So I'm going to do it for this one. -13 minus -8 is also -5. That's a good sign that these match. That's making me think that it is arithmetic because we're adding -5 each time. But we have to try these last two. So -18 minus -13 is -5. And -23 minus -18 is -5. And so if you're adding by the same amount every time, the type of sequence is arithmetic. And that means it has a common difference. So arithmetic always has a difference, geometric always has a ratio. And then what's the value of that difference? Well, that's the number that you find each time. It's important that you go from second to first because we want to make sure we get the number that you actually are adding. -3 plus -5 should equal the next number. And if you want to double check to make sure you have the right number, just do that on a calculator. -3 plus, because it's adding, -5 is -8. -8 plus -5 is -13. And so you want to make sure it's whatever you're adding by, so that value is -5. And then to get the next three terms, I'm just going to add -5 to each one. So -23 plus -5 is -28. Plus -5 is -33. And then -38. So now let's do another one. So we have 5, 3, 1, 5, 3, 1. So we can kind of see the pattern. 5, 3, 1, 5, 3, 1, 5, 3, 1. We want to see if we are adding the same number each time. So 3 minus 5 is -2. 1 minus 3 is -2. But then 5 minus 1 is 4. So all of them have to match. Since this one does not, it is not arithmetic. It does not automatically mean that it is geometric, though, because now I need to figure out if I'm multiplying by the same thing each time. So instead of subtracting, I'm going to do division. So 3 divided by 5 is 0.6. 1 divided by 3 is 0.3 repeating. So automatically these do not match. So arithmetic ones didn't match, geometric ones didn't match. So this is neither. There's a pattern, it's just not an arithmetic or geometric pattern. So because it's neither, it does not have a common difference or ratio. We don't know the value, but we can do the next three terms. We can see the pattern: 5, 3, 1, 5, 3, 1, 5, 3, 1. So let's do this last one. So one of the telltale signs that it's geometric is if the signs change. So if it goes positive, negative, positive, negative, positive, negative, the only way to get that is if you're multiplying by a negative number. So automatically, I think this is geometric. You can test out arithmetic if you want. -6 minus 3 is -9. And then 12 minus -6 is 18. And those don't match. So it's not arithmetic. So now geometric, I want to divide. So -6 divided by 3 is -2. 12 divided by -6 is -2. And -24 divided by 12 is -2. And so this is geometric. That means it has a common ratio. The value is whatever we're multiplying by to get to the first, from the first number to the second. So 3 times -2 gives me -6. So my value is -2. And then the next three terms, I can multiply by -2 each time. So -24 times -22 is a positive 48. 48 times a -2 is a -96. And then a positive 192. So the big mistakes are, one, you just have to make sure you know that geometric and ratio go together and arithmetic and difference go together. And then the second thing is make sure you always go second term to first term to figure out what your value is. So when you're dividing, do second divided by first. When you're subtracting, do second minus first to see what this is.